Hi, this is Bill Reese, and in this video, we're going to talk about the spreadsheet that is titled the MVE Portfolio with two risky assets. So let me pull that up on screen share so we can go over it and make sure we understand exactly what is being done in this particular spreadsheet. Well, this looks a lot like the last spreadsheet. We've got asset X and we've got asset Y. Conveniently, it's the same X and Y with the same expected returns, same standard deviations. The variances are calculated here. We've set the correlation at 0.1. Okay, we're going to just kind of leave that as the correlation between X and Y here. Here is then the covariance being calculated. And what we've added on this spreadsheet, which was not on the prior one, is the risk-free asset. Our risk-free asset has a rate of return of 5%. And of course, its standard deviation is 0. So here is X and here is Y. And here is the risk-free asset with a expected return of 5 and a standard deviation of 0. This is all pretty much what we saw in the last spreadsheet, except that we're now allowing for some negative weights on X and Y. So we're seeing here if we have a negative weight of 30% on X, okay, then 1 minus negative 30% means the weight on Y is 130%. So what does that mean to have a weight of 130% on Y and a weight on X of being negative 30%? It means we are shorting X, and the money we get from shorting X, right, means we're borrowing some shares of X, and which doesn't cost us anything to borrow them, and we're selling them. And when we sell them, we get some money. Okay. What do we do with that money? We invest it into Y. So we're investing all of our money, 100% of our money into Y, plus an additional 30% that we got from selling the shares of X that we borrowed, which is shorting X. And what does that do? That allows us to go up here, okay, on the hyperbola, where we have more than 100% of our money in Y and a negative weighting on X. And we can see here it is, for example, the expected return on the portfolio is 23%. Standard deviation is this. And then here is the variance, which is, of course, the standard deviation squared on that. Okay. Now, to get down here, we probably wouldn't want to go down here, but to get down here, what would we do? We would actually short Y and put more than 100% of our money into X. And that would be what you would do down here. You've got 130% of my money in X. How did I get 130% of my money? Well, I borrowed some shares of Y and I sold them, giving us some money. And what do I do with that money? I invest it into X. So I've got 130% of my money invested into X with a negative weight, which means shorting or borrowing on Y. And here's the expected return standard deviation there. Okay. So that allows us to go down here, and it could go down further if I just wanted to plug it in for more shorting there. And this one could go up even further as well. But we've got the hyperbola that we learned about earlier. And what we want to do here in this situation is we want to find the mean variance efficient portfolio, the MVE. The mean variance efficient portfolio is going to be the combination of X and Y for which the Sharpe ratio is maximized. It's going to be where the capital allocation line is just tangent to this hyperbola. Now, when you open it up, we've already got the solution. The solution, we can see it's right here, and these are the values. Let's change that so we can see how we will actually find those if the solution isn't automatically given to us. So we go up here, and we're going to have solve for us the weight on X that creates the MVE, or that finds it for us. So for right now, let's just put 100% of my money into X, okay? So if and it's not a very pretty graph, okay, but now the weight on X is 100%. The weight on Y is 1 minus the weight on X, right? So our money has to be a portion between X and Y. And so we've got, if I've got all my money in X, there's no money in Y. Now, what's the expected return on the portfolio? Again, that is going to be the expected return on X times the weight on X plus the expected return on Y times the weight on Y, which If I've got all my money into X, that's 10% because that is the expected return on X over there. What's the standard deviation of the portfolio? Well, again, if I've got all my money on X, it's going to be 7% because that's the standard deviation on X. But this is the formula for the standard deviation of a portfolio where you've got two risky assets, X and Y. Just so happens I've got none of my money in Y at this point in time. So the standard deviation of the portfolio is going to be the standard deviation of X. Here's the Sharpe ratio. Okay, the Sharpe ratio is going to be the expected return on the portfolio right here. That's going to be cell J5 minus the risk-free rate, cell C10, divided by the standard deviation of the portfolio, which is in cell J6. So what's going to happen is when I change the weight on X, or solver is going to be changing the weight on X, that's going to change the expected return on the portfolio. It's going to change the standard deviation of the portfolio. And as it won't change the risk-free rate, but as the expected return on my portfolio and the standard deviation of my portfolio get changed, that will change the Sharpe ratio. And we're going to have solver find what needs to be the weight on X that will maximize the Sharpe ratio. That's going to say, hey, where is the point on this hyperbola here where this line, okay, this capital allocation line coming from the risk-free asset here goes up and is just tangent to the hyperbola. So we're going to go into data. We go into solver here, and we've got solver we bring up, and we're going to say what we want to do. My objective cell is going to be the Sharpe ratio. That's what I want to do. What do I want to do? With the Sharpe ratio, I want to maximize it. So I can go to maximize, and I'm going to do that by changing the weight on X. Okay, so we're going to say how much of my money goes into X, which will then affect, of course, how much money goes into my money goes into Y, to be able to get the Sharpe ratio as high as possible. There's no constraints here. I'm not saying, hey, something needs to be a certain value here. We don't need to have any constraints, and we make sure that this is not checked off. Okay, I think it's just a general rule. You don't ever want to check that off, because if you do, you'll probably forget to uncheck it at some point in time, and then you'll eliminate the possibility of some negative weights when you want negative weights. So we hit solve, and solver says, hey, I've got an answer for you. And what is the answer? It says the highest you can get on the Sharpe ratio is 1.6036. And how do we get that? Well, if we put 36.07% of our money into X and 63.93% of our money into stock Y, then the expected return on the portfolio is going to be 16.39%. That's going to be right here. You can see that's at 16.39%. The standard deviation of the portfolio is going to be 7.10%. You can see that right down there, 7.10%. And then this line, the solid line right here, which is going to be our capital allocation line, which goes through the MVE, is just tangent to the hyperbola. So where is the optimal place for a risk-averse investor to be? Somewhere on that solid line. That's going to give you the highest expected return with the lowest standard deviation. Nobody wants to be anywhere on this line that goes through X, okay, because the solid line is much better. It's further northwest. Nobody wants to be on this dotted dashed line that goes through Y, because again, you can be better off on this solid line. Nobody even wants to be anywhere on the hyperbola, because except maybe if they wanted to be right here at the MVE, because everything on that solid line is better than every point on the hyperbola, except, of course, the MVE is a point on the solid line and it is a point on the hyperbola. So how do we get to the MVE? We put 63.93% of my money in Y, 36.07% of my money into X. How would we get up here if we wanted to be there? Well, then what we're going to be doing is we are going to be putting 100% of our money into the MVE, and we are going to be borrowing at the risk-free rate, which gives us some extra money to put more than 100% of our money into the MVE, and that will allow us to get up here. How do we get down here? Well, we're going to put some of our money into the MVE. In other words, we got some of our money. Let's say we've got $100, okay? Then I would put $70 into the MVE, which means I've got $70 that will be allocated in these specific proportions right there. Okay. And then the other $30 would go into the risk-free asset. So putting some of my money into the MVE and some of my money into the risk-free asset will allow me to be down here on the solid line. If I put all my money into the MVE and nothing into the risk-free asset, that puts me at that point. If I put all my money into the MVE, I borrow some money at the risk-free rate and put that also into the MVE. That allows me to get up here on this solid line. So the combinations of X and Y are going to be set at these two values wherever I go on that solid line. The only thing that changes the solid line, where I'm on the solid line, is what I'm doing with the risk-free asset. Am I borrowing at the risk-free rate? Am I lending at the risk-free rate? Is going to be determining where I go there and how much money I actually have going into the MVE. More money going into the MVE puts me up here. Less money going into the MVE puts us down here. So the main thing I wanted you to get out of this is, how do we find the MVE? We find it by using Solver to maximize our Sharpe ratio. Change some of these numbers around, get some practice with it so that you will be able to do that as well when you don't have these exact same values given to you.